Good morning, ladies and gentlemen. It is our pleasure to welcome you all again at the second day of our symposium entitled From the Infinite Cosmos to the Basis of Existence. Let us continue to explore together the concept of research and frontiers through the three interconnected dimensions: space, Earth, and the inner self.
So thank you, Thomai. Looking forward to another productive session within our symposium. Since the theme of our fourth symposium is research on space, Earth, and the inner self, Thomai, actually, who is a high school teacher, had an idea to get some input from students to do a mini research project, not in the traditional academic way, in a more, allow me to say, authentic, spontaneous way, because young people, they are the future, and it was a really good way to get involved in the symposium by getting some feedback based on some questions and inquiries on space itself. So thank you, Thomai, for the wonderful idea. So we gathered some data, and Nikolaos will actually share with us some results.
Good morning. Thank you, Chrysostomos. So I'm going to present this data in a non-traditional way, totally rational. But I thought it will be a good starting point for the next, for speakers, for Vladimir and Patxi, maybe if they would like to comment on those as well. That's why it was decided to do it right now. It will take less than 40 minutes. So there were 37 students, 37 participants, 15 English speaking, 22 Greek speaking. Age ranges between 12 and 18. The most common age was 15. And for the Greek group, the most common age was 17, between 14 and 18. So high school students. The questions posed to them was, the first is, what do you consider to be the biggest question that humans have about the universe today? They offered 4 choices. How was it created? Is there life elsewhere? Does it have an end? Does it have a purpose? Second, what is the most important for human progress in space? Technology, imagination, cooperation, and faith. Third, when you look at the night sky, what do you think about most often? How small I am? How much we don't know? What is out there? I feel peaceful. The fourth question refers to, would you like to participate in a space program? Yes for science, yes for experience, no it scares me, maybe if there was safety. The fifth, where is the universe would you like to go? Another planet, a different sun, another galaxy, a black hole maybe. Sixth, why do humans seek extraterrestrial contact? Out of boredom, out of curiosity, because they believe they have experienced everything on Earth, because they believe they need it. And people say we are all stardust. What does it mean to you? So they offered also 4 answers. Question number 8, China sent moon dust to the UK. It was described as more valuable than gold. Do you think that is true? And 9 is, space missions are now carried out for recreational purposes. I consider this cosmic event, good development, waste of money, human vanity. And the 10th question was an open question. So some data is presented here. And the summary of the results is, and the 10th question, before going to the summary, is that it was an open-ended question. If you meet an astronaut, what would you like to ask or learn? So I tried to categorize those answers. Actually, the answers it was mostly emotional. How Earth is seen from above, if there is life beyond Earth, fear and adaptation, and zero gravity experience. That was the themes of the answers to make it as a category, not the actual answers. That I chose 3 favorite questions. The first is, how do you overcome the fear of the unknown? Maybe it's something that we can discuss. It's about fear. What did it feel like to see Earth from space? That's another also question that everybody can say his opinion if they like to. And can humans live beyond Earth? I think we kind of answered this question yesterday. Well, I don't want to go to the interpretation. The thing is that most people considered the answers given. We have the data, so everybody that is in this, I can share the data with them. But what I saw from young children is that for question number, let's say, 1, there was if it doesn't have a purpose. So young children considered if there is a purpose, actually. What is the most important for human progress in space? Believe it or not, both Greek and most Swedish students has said that it's technology. So what I mean to say that people, students from Sweden and students from Greece, they have the common answers. So students are at that age are not yet influenced from their background. They are as innocent as possible. So that was a very nice fight, as I interpret it. Of course, it's a very small. I'm not overstepping scientific data and stuff like that, but just a preliminary thing that we saw. When you look at the night sky, what do you think about most often? Is that it's how much we don't know. I saw humility in their answers, so it's nice. And I said it's 70%, 80% of the answers. It's not like 30 or 40%. It's the majority of the answers. And would you like to participate in a space program? Well, fortunately, they say most of them they say no. It scares me. So it's like fear. Most of them. Where in the universe would you like to go? Most of them answer, and I totally am with them. Not even in another planet. They would like to go to another galaxy. So yeah, not even Earth. So considering going to the moon or Mars, I think it's not the deal. We have to find a way to go to another galaxy if we like to satisfy our youth. Why do humans seek extraterrestrial contact? The answer that because they believe they need it. So it's the fourth question. That was also very interesting. And number 7, people say that we are all stardust. What does that mean to you? Of course, that we are part of in the universe, so they answered that. China sent moon dust to the UK. It was described as more valuable than gold. Do you think that is true? 70-80% answered maybe, but so they are not so sentimental about these things. And number 9, and I will, so we can continue. Space missions are now carried out for recreational purposes. I consider this good development. If I remember correctly, 85% they think this is a very good development. It's a good development. The rest was half. It was waste of money and human vanity. But I consider that a small percentage. It's a small group of participants, but you can take something out of it. I mean, we didn't consider anything else. We just gave the questions away and they answered if they wanted to. All right. So if you like to comment on that, after that, it will be my pleasure. Thank you. So, Chrysostomos? To the students, not to me.
Our first keynote speaker, Vladimir, will be discussing today living in space. How far can we go? Please, can you open it for me?
Thank you. And good morning again. I'm happy to see you that you're all there and full of energy, although it's early morning. Well, 10 a.m. It's early morning. Yes. So let's go into space. I would like to take you to a little voyage for the next half an hour to the outskirts of Earth, and imagine that we leave our planet and we go not only in a solar system, not only in our galaxy, but even further. We will consider the entire universe. And I would like to try to give you an idea of the size of the universe and how far is it. And you will see it's not easy to understand sometimes. Okay, so how far can we go? Let's try. First thing that you have to realize that the universe is big. Imagine something that is big, the biggest thing that you can imagine. Think about it. Well, it's even bigger than that. Try to put a number on it. How many kilometers? How many millions of kilometers? How many billions of kilometers? A very large number. Think about it. It's even bigger than that. So, 100 billions of galaxies. 100 billions. Billions. It's enormous. 100 billions. It's 10 to the power 11. This is an estimate. So we didn't count them because it's already enormous. It's an estimate, 100 billions of galaxies in the observable universe, only what we can see. The thing that's very important as well, because we do not know what is outside the boundary of what we see. What we see is what the light carry as an visual information to us. The universe was born 14.6 billion years ago. 14.6 billion years ago. So what we can see is 14.6 billion light years. And light years, definition of a light year is not the year where it's very sunny. No, it's the year that, it's the distance that the light would go during 1 year at the speed of 300,000 kilometers per second. So multiply by the number of seconds in a minute, number of minutes in an hour, number of hours in a day, number of days in a year, number of year. And this gives you an idea. It's several billions of kilometers already. Light is the fastest thing that we know. Photon, that are the particle of light, are the fastest thing that we know in the universe. So physics have hypothetical other particle that can go faster than light, but this is hypothetical. It was never observed. So light is the fastest thing that we know, 300,000 kilometers. And even at the scale of the universe, is so slow, desperately slow. And in each galaxy, hundreds of billions of stars, hundreds of billions. That's again 10 to the power 11, which means that in the universe, and again, this is an estimate. And we know now that actually this estimate, this is a low estimate, it's probably much higher than that. Which means that it means that in the observable universe, there are 10 to the power 22, which is billions of billions of billions of stars in the entire observable universe. It's enormous. So where are we in all that? Well, this is one galaxy, completely normal, completely, absolutely anodyne, absolutely, let's say, without anything particular. It's a flat galaxy, spiral galaxy. You see the central, here, the central nucleus, and then several arms that are rotating around it in spiral. This is called a spiral galaxy. The size of it is about, from here to there, it's about 100,000 light years. So a photon to go from here to there takes 100,000 years, means 1,000 centuries at the speed of 300 kilometers per second. So it's enormous. But that's only one galaxy among 100 billions of galaxies, okay? This is actually our galaxy. This is the Milky Way. It's a galaxy absolutely normal, nothing extraordinary about it. And our sun, our star is somewhere in that galaxy. Do you know where? Any idea where it could be? Somewhere. Yeah, somewhere there, exactly. Perfectly, Nikos. It's actually here. So you were not far. But that means that, in fact, our sun, our star, is somewhere on the boundary of this galaxy, of the Milky Way, not even in the center, luckily, because their gravity is much, much higher, and we think that there is a black hole there, so we better stay away from it. But it's one of the arms the Orion spur arm that, sorry, in the big Perseus arm that we are located. And if we zoom on that, we are actually one star. I mean, our sun is only one star among many other stars in this spiral arm. So nothing extraordinary about that. We are not even in the center. And our galaxy is not even in the center of the universe as well. So where are we in all that? I mean, we, our planet, basically, we lost in that. We are just there, pointing. So, very precisely, this is our home. This is where we are. More precisely, again, here, somewhere in the middle, and it's called a little pale blue dot. It's Carl Sagan who said that, a famous astrophysicist. Unfortunately, who died very young of cancer many years ago, well, some years ago, last century. But his quotation, and this picture was taken by one of the Voyager spacecraft that went explore the outer part of our solar system. And he had the idea, well, ask him to turn it back and to take a picture, took a photo of our planet from far distant. Well, far distant, it's only a few million kilometers, compared to the size that I was telling you, 100,000 light years. So it's another scale, of course. Let's have a look then in our close surrounding. This is a family photo, family picture of all the planets in our solar system. But this was a bit photoshopping, with family, you have people who are old people, you like to do a bit of photoshopping. Exactly that we did here as well. And we photoshopped this family picture just to keep them, everybody, all the planet on the same picture. Because in fact, the distance between the planets actually doubling each time. So it would be much more extended, of course. But here, for the sake of the picture, we put them all together. So we just gather them all together. We are somewhere here. You see, it's pointed here, the third planet coming from the sun. This gives you an idea of the size of the sun. Remember, the sun is perfectly normal, standard star, nothing extraordinary. But it's big with respect to our planet, you see. It's a huge ball of fire. When I say fire, it's not exactly correct. It's mainly hydrogen, a bit of helium, and it burns. It goes through transformative process, so nuclear reaction to transform hydrogen into helium that produce a lot of energy that we receive here in terms of heat, infrared, and light, visible light as well. And all other frequency as well, but which are blocked by our atmosphere and magnetic field. But what you see as well is that there are other stars, much larger and bigger than ours, which are the giant planets. Jupiter is the biggest one, mainly gas, but of course there's a central core, which is solid. Saturn, with its rings. Actually, we found rings in all the giant planets, but Saturn is well known for its system of rings. Uranus and Neptune have also rings, smaller but still giant. And then on the outskirts, Pluto was known as a planet, but since now 30 years, 35 years, other planets, small planets, have been discovered in that surrounding. And it was absolutely crazy to start to continue to call them all planets. So it was decided in early 2000 to put Pluto in a new group of family, call them planetoids, or small little planets, because some of new planets were even bigger, that were discovered were even bigger than Pluto. And like between Mars and Jupiter here, there's another family of small body that we call asteroids that are placed there. Let's come back here to the small planet. Small planet is exactly the word, because they have absolutely nothing extraordinary as well. We are lucky to be here on the third planet because we are not too far from the sun, because all these planets are giant ice planets. The temperature drops well below 0 degrees, so water freezes all the time. But I'll tell you a little bit more about that in a second. We are lucky also to be not too close from the star, because there, well, for example, Mercury here has no atmosphere and is completely burned by the sun because it's too close. Venus has clouds, but the temperature is typically 400 degrees centigrade. Luckily, we are in between. Mars, a bit further, Okay, still a bit cold, but not that cold. Sometimes temperature can go up to 20 degrees on the equator when the sun shines. There's not too many clouds, but it's still much colder than it. So we are lucky here that we are here and that life emerged on Earth many years ago, 4.5 million years ago, more or less, and evolved on Earth to eventually give who we are, mankind. The question is, could life have evolved somewhere else in the universe? We still have no answer to that. But okay, that's just to give you an idea of the size. If we go quickly through the planet, where we know there's life and where we maybe expect there's life. This is Earth, we know, very beautiful planet, a pale blue dot. Mars, as I said, a bit further, still cold, but not too cold. And we think that maybe life could have existed in the past because somehow the condition for the emergence of for the apparition of life appeared there much earlier than on Earth. So life could have existed on Mars, and we are still looking whether life still could exist, maybe underground, under the surface of the planet, because Mars has no magnetic field, has very tiny atmosphere, and it doesn't stop radiation coming from the sun. So life today cannot exist on the surface of Mars because radiation would have absolutely burned it. So Mars could be a candidate. And very surprisingly, as I told you, the giant planets are ice planets because it's so cold, because it's much further from the sun, so it receives very little light and heat from the sun. But we discovered that due to its gravity, the satellite of Jupiter, sorry, wrong button, there we go. Some of the satellites of Jupiter are in tidal lock, which means that they are rotating, revolving around the planet, but the gravity makes them rotate in groups of pairs or three. This is called resonance, and the famous resonance between the first three, Io, Europe, and Ganymede, that lock them in tidal lock, and that creates friction inside, which elevate the temperature in the satellite. And this elevation of temperature, well, makes it that the icy surface of some of these satellites, the icy surface, say icy, but underneath there is a liquid ocean, liquid water, basically, with salt, and that could be giving it's the basic, let's say, for apparition, for the emergence of life. Another candidate, satellite of Saturn. I'll show you Saturn all around. Saturn has a system of satellites very, very strange because there's a really large satellite called Titan here, a big one, with an atmosphere, mainly methane, and then a lot of small satellites, which at the beginning we thought, well, just be rock, and icy rock, basically completely evolved of anything, except that one of the mission found that here, Enceladus, has also ocean, liquid ocean underneath an icy crust. And even more than that, there are geysers, like volcano, cryovolcanism, that eject this icy liquid, let's say, in space. And one of the spacecraft flew through that plume and could measure in situ that there are still also molecules that resemble of precursor of life. So Enceladus could be also one of the candidates for life in the solar system, which is absolutely stunning. At the other planetary system, yes, of course, we found quite a lot. This is one example, the Andromeda system. You see, with respect to the same scale, the inner planet of the solar system, so Mercury, Venus, Earth, Mars, and you see larger planet at more or less the same distance. So it means that around other stars, there might be planets which are somehow resembling Earth. This is one example. But we are limited by our means to visualize them. And again, I want to emphasize this. We never traveled to this planet. There was no spacecraft that was sent to this planet. It's only discovery by using telescope and some techniques of light diminution and so on. So we can only use our imagination to imagine how it is looking on the surface. Other solar planets, yeah, quite a lot actually. Well, these are a few. Today we know that, until 5 June, so when is that? 3 weeks ago, we knew that there were 5,917 planets who were confirmed in 4,413 planetary systems, so several planets around one star, and still counting. Means that there are thousands and thousands of other events that were seen, measured, but not yet confirmed. So scientists are extremely cautious, and before saying that, okay, we discovered something, they want to make confirmation, verification, and so on. But the interesting thing is that all these planets were found in a very close neighborhood of the sun, typically 300 light years. 300 light years is very small, but again, it's very big. Imagine that light takes 3 centuries to go from one side of the surrounding around the sun. And within this close surrounding, we found most of these planets, which means that we still do not know a lot about the rest of our own galaxy. Okay? Which means that also the 100 billions of other galaxies, we have no idea what is there. We know that there are stars because we see them, but we don't know whether there are other planets there. Can we travel there? Too far. Can we travel even to one of those stars? Too far. The closest stars is Proxima Centauri, alpha of the constellation of Centaurs. Proxima Centauri, which is at 4.2 light years. So even to go there at the speed of light, impossible. Physically, for us, impossible. But at the speed of light, it would still take us 4 years, a little bit more than 4 years to go. We are very limited, in fact. The object that went the furthest is actually Voyager 1, which is here. It was launched the 5th September 1977, so nearly 50 years ago, so 48 years ago. It did the flyby of Jupiter in 79, Saturn in 1980, actually just in time for me to work on the result for my PhD at that time, which was very interesting. And it's currently the farthest human-made object at 24.9 billions of kilometers. That's quite a lot, huh? But still, it's only 2.6 milli-light years, so 2.6 to the 10 multiplied by 10 minus 3. It's very small distance with respect to the scale of the universe. But it's still quite far for us, man-made object. So that means that we are not even exploring the rest of the universe or the other stars of our own galaxy, but we are still bound inside our own solar system here. And recently means a couple of weeks, 2 weeks ago, 10 days, 2 weeks ago, Voyager 1 just passed the barrier, the frontier, the border of the solar system, and to entering into the interstellar medium. And he made a discovery, which is very important, that was not known before, that the temperature suddenly increased tremendously at this shock of the radiation coming from the rest of the galaxy to the bubble, let's say, created by the magnetic field of the sun. And these temperatures are typically of the order of 40 to 50,000 degrees. Very low density, but this temperature barrier, this heat barrier, would make it impossible for us humans to cross against it, to cross through it. So we are limited. We to stay for quite some time until we find a way to travel first that far, and then also to overcome this frontier, natural frontier, to travel further. And you see also in this picture here, the sun in the middle, the different planets all around. We are very close here to the sun. That we still a very tiny speck of dust in the universe. We're living on that, so we are little ants on this speck of dust in the universe, and we try to explore around us. Luckily, nature gave us a brain. I mean, to most of us, well, some of us, most of us, and to try to understand by what we see, by doing this research, this observation. And we see that basically we are still nowhere. There's so many things that we do not know, so many things that we try to understand, but with limited means, observation-wise. So we have telescope, we have radio telescope, so we can see, we think we can see quite a lot, we think we can understand quite a lot, and it's true, we made huge progress compared to a few centuries ago, but we're still nowhere in the understanding of the universe. And one of the limitations is basically the distance, that we do not have even the theoretical, physical theoretical means to do more than that, because we are limited by the speed of light, 300,000 kilometers per second. We cannot go faster than that, and we cannot explore further than simply that, farther than simply that. So, are we limited? Yes, we are. So, what should we do? For the moment, we should content ourselves with explore our own little backyard, basically, or our own little neighborhood. And this is typically what we do. I told you a little bit about the Artemis program yesterday, that the new president of the mighty United States of America decided in his immense wisdom maybe to underfund it, but still this program is existing. And the first thing is to return to the moon and study the south pole of the moon, because we know that there's ice there, water ice in one of the craters in the south pole, and this water ice can be used to sustain a first basis, human base, human location there, temporary first, and then eventually permanent. So that would would allow the human race to expand and to set foot permanently on another celestial body. Not yet another planet, but simply our own satellite. And again, it's a huge step, but when you think about the size of the universe, it's such a microscopic little step. We have so much else to discover and to explore. So we're still on Earth, but tomorrow these will be our homes, the moon first, Mars later on in a few tens of years or so. And I would like to stop here. I guess I'm still in time. And I thank you for your attention. And we could discuss later on if you have time. Thank you.
Thank you so much, Vladimir, for for delivering such a captivating keynote. It meant your participation meant a great deal for us. Many, many thanks. Next, we are honored to have again with us Patxi. Patxi will be presenting a talk entitled Harnessing Earth's Potential, Innovation for a Sustainable Future.
Okay. Good morning, everyone. Thanks for having me again. Let's gonna do a small talk. We're gonna try to talk about a little bit about AI, UAVs. I think I will skip a little bit sustainability, and I will go a little bit. Well, you know me already. We're gonna go a little bit about the differentiation, UAV, drones, UAMs. What is unmanned aviation? What is today AI in aviation? And then I want to finish with a personal point of view of what is today research in academia and in general this topic. Aviation, as we know, beautiful aircraft and things that fly, but it's a bit different. So we're gonna try to do this a little bit together, and we're gonna first start with the question: what is an aircraft? Right? An aircraft is any machine supported for flight in the air or by buoyancy, or by the dynamic action of this air on its surfaces. That means that both a balloon, an aircraft, a glider, or a paper plane that you throw is an aircraft. So, let me tell you a story. To give you a quick introduction, we're going to go over this a little bit fast, but I want to start from the very beginning. So give you an understanding of what aviation is and how it came to be. We're going to start taking a little plane, and this plane is going to travel in time. So we're going to take this plane and we're going to go back to the past. I'm going to go to the ancient Greek. And we're going to start with the first Icarus myth. So we know that, or possibly you know very well, that Icarus attempted to escape from Crete, and then he had some wings made with feathers and wax, and he was warned, don't fly too close to the sun, because it might melt and you fall. And, well, as you all know, he did, and he fell. So that was kind of like the first indication of flying. And then if we carry on in our little plane, we carry on forward, we can go to the 1010 AD. And then we have Sir Aylmer of Milnesbury. He was a monk that allegedly he flew from the top of a cathedral with some attached wings, and he believed in the tale of Icarus. He wanted to do the same. And we don't have direct information from Aylmer, but William of Milnesbury wrote about him. And apparently he actually did fly, because he jumped, because William said that he actually flew around 200 meters, and actually he broke his legs and his ribs, and he said that it fails because the wing didn't have tail. So that's not very scientific, but it's a written information that we have already in our times. Let's carry on flying a little bit over the time, and then let's go for 1485. So let's go to the Renaissance era, and maybe all you know what is going to come in. So in this time, we have a very small person in Florence, in Italy, who did a lot of sketches about aircraft machines and flying machines. And of course, as you know, we talk about Leonardo da Vinci. So he foresaw flying machines that can actually fly through the air, and he envisioned what is aviation, because he envisioned these flying machines for a purpose, for doing something in particular. Then we can carry on flying a little bit until 1783. And then, sorry, I have bad voice today. And then we have the first manned flight, which was a balloon by the Montgolfier brothers. And I would like to stop a little bit here about Montgolfier brothers and talk a little bit more about them, because it seems very interesting. They did the first manned flight in 19 October 73. They were educated in chemistry and everything. They were the sons of a paper manufacturer, and they were believing into this because the story goes as such. So one of the brothers was actually writing a letter next to the fire, and then next to the fire was his dirty clothes washed, and they were getting dry. And then he realized that the dirty clothes were actually lifting next to the fire. And then he believed that he just discovered a new gas, which he called Montgolfier gas. And this gas was creating a force that was lifting the clothes. And for some reason, he believed that the more stinky the smell was, the more powerful the gas was. So his experiments were not very welcome in the community, as you can imagine. But anyway, he pursued his career, and then he started to envision that he could actually use Montgolfier gas to actually make a balloon and fly the balloon. And he spoke with his brother, and they came up with, let's make a balloon made out of paper, because they were very good at making things with paper. And so they did. The first flight balloon was in 1783 with no passengers, made everything out of paper, as you can see here. And the first flight with passengers was on the 19th of September of 73. Can you imagine who were the first passengers? It was a cook, a sheep, and a duck. So that was the first passengers ever flying and leaving Earth on history, or at least written history. So they became famous, and then they did the first manned flight tether, and it was in October 73. Although there is a story that one of the other brothers did before, because he was doing a test with the tether, and then he actually accidentally lifted, and it was not legal, but theoretically it was before. Anyway, a balloon was made out of paper, tested, and there were some important people involved, and then you have some untethered first flight, November 1783, and then there was some other people using hydrogen at the same time. Hydrogen was already discovered, and then there was another person doing the same as them, but rather than Montgolfier gas, which was basically hot air, they were doing it with hydrogen. As a note, this flight was observed by a person called Benjamin Franklin, if it rings a bell, and he actually wrote about this flight in his diaries. Well, people die as well. So, let's go a bit forward more, and then we go to 1799, and we got George Cayley. And George Cayley basically was first aeronautical engineer. He discovered all the forces involved in flying, and basically he also was a very prolific engineer. He also discovered and created the dihedral angle and the wheels that we use today, all the tension wheels. So he was very prolific, but he was referred as the very first aeronautical engineer. And then we go to 1986. We're going to skip this guy. It's airships. We're going to skip it. 1986, we have Samuel Prideaux Langley, and I want you to focus in Langley's surname. And this man, he did the first heavier-than-air aircraft, powered. So the first aircraft with a sort of engine flying, it was in 1986. It was on pilot, so that means that we can consider it almost like a drone. So the first thing that flew, it was not the Wright brothers, it was actually a drone. Although it's not fully a drone because it was not active control, but he actually flew with his motor flight, and he flew quite good distance. And Langley, of course, as I said, focus on the name, because the NASA Center, Langley Center, is named after him. And then, of course, 1903, we have Orville and Wilbur, which we have the Wright brothers, which they flew unmanned with a power aircraft in 1903. The previous one was a steam engine. This is an internal combustion engine. That's the difference. And this one has full control. Okay, so let's go a bit more faster. So now we know. So what does an aircraft? Why does an aircraft fly? That's the next question I want to ask you. Now that you know all the story, how it becomes, you know the forces, why an aircraft flies? Now it's correct. It's because we have some magic everywhere happening, and that's why an aircraft flies. A bit of magic here, a bit of magic there, and that's why we fly. Yeah, okay. So let's dive now a little bit into, now that you are acquainted with aviation and with Samuel Langley, I know what he did with the different number 5 and number 6 drones, wrongly called. A drone basically is something that you can control and you are not on board. You can have both airplanes, helicopters, or anything that flies. So the term drone gained popularity very late, in the late 2000s, 2010s. Before, it used to be called a manned aerial vehicles, or UAVs. And that was because companies like DJI became very popular. It started to create more and more commercial vehicles, and that's how we end up having the term drone, floating everything. So drone, what is a drone, right? So originally in the 70s, drones were used by the military as a target for pilots to practice. This was a drone, they launched it, they were remote piloted, and then the pilot in the aircraft will do dogfighting with this drone, so they will actively shooting it down, but you don't sacrifice any aircraft. Then we had commercial drones as we know it, where DJI and other companies started to say we can utilize this technology for selling a product. They created a new market niche. And this type of business evolved into a more commercial business, because originally it was just simply recreational. And now we have cinematography, we have agriculture with drones that can weigh up to 100 kilograms and lift up to 70 kilograms. And we have also even new specialty, firefighting, deliveries of blood, and very specialized things. And of course, lately we have drones used for war. So now the other topic that I want to introduce you is, we already talked about the aviation, we already talked about the drones, and now it's urban air mobility. And I presented you yesterday a little bit about the urban air mobility that we did in Chalmers. Urban air mobility is a new transport system that it was starting to gain popularity around mid-2000s, early 2000s, because it was foresaw by United Nations that 80% of the population will live in cities by 2050. And I think about it, we are like 7-8 billion people on Earth, 80% of the population living in cities. That means that we're not gonna have large cities. We're gonna have megalopolis. We're gonna have massive cities. Road transport cannot cope. There will be not sufficient roads to sufficiently give service to everyone. So some smart people started to think, well, you know, we have 2 dimensions totally occupied. Why don't we use the third one? Why don't we use what we have above us? So started to think like we can actually use the airspace between the cities to do another, you know, hop on, hop off flight system, and that's how this type of vehicles started to be envisioned. There are 3 types mainly of type of vehicles that differentiate them from another type of vehicles like helicopters. And it's basically because you have either a wingless, which we call a multicopter, and it's basically a rotor that flies up and down, and you fly in and out. You have lift and cruise, which means you have wings to help you to go, and then the wings rotate entirely, but the rotors don't. And then you have vector thrust, where you have the rotors rotating, which is kind of like the one that is gaining more popularity lately. If you check Joby Aviation, which is backed up by Amazon, is using this type of technology. So it has some benefits that we think they will solve the problem of the megalopolis. But in my point of view, it's not only for urban air mobility. We can actually use them as for rural areas where are very inaccessible or they're very far away, and you cannot justify to have a high-cost helicopter or any other means. You can use this type of vehicles to help you in your day-by-day services. And that's urban air mobility. Then in general, UAS stands for Unmanned Aircraft System, and that's actually the box that contains everything. It's the box that contains drones, that contains UAVs, that contains UAMs, that contains ground stations, control tower, and everything that managed unmanned aviation, meaning no one is on board. And UAS contemplates both remote piloted and autonomous flying. So it's just you don't have anyone inside what is flying. So this is a huge topic because we want to try to make ground stations as automated as possible because normally autonomous, talking with autonomous, or automation talking with automation is relatively simple because it's just ones and zeros, it's software coding. But trying to make some software coding speak with a human brain, that's a bit more challenging. And I know that you think in ChatGPT, we're going to go over it, but it's not as simple as you think. So there is a big problem into that. Current air traffic controllers do not want to press a single more button. So they say, look, this is very nice, but we don't want to work more. So you need to make it in such a way that it's fully automatic, it's safe, and it doesn't overload us. So that's what we are working on, different systems and different technologies proposed by different people, all of them very interested. So unmanned aviation. UAVs, right? We understand this as a UAV, we understand this as a drone. But what if I tell you that UAVs, and most of them are remote, there's a human behind. Most of them, there's always a human behind. So can we call it unmanned aviation? People will think, yes, we can call it unmanned aviation because the pilot is not on board, but it's not usually fully autonomous. How about rocket missiles? Or spacecraft? Or airplanes? Are they unmanned? So what is really unmanned in aviation? That's the question we should ask. What if I tell you that we can do a comparison of this one with the car industry, right? You have a car, some of you have more modern cars, and this is taken from the car industry. You have no automation, you have full automation. This high automation is a Tesla. This one, we are not yet there, right? This will be the Knight Rider or something like this, you know, the kit. So we're trying to get there, but we are not there. So if we break it down, the 0 and 1 will be this type of cars. You have very simple controls, no automation. Everything depends on the driver. Maybe you have something for the wipers, maybe something things like this, or the blinkers, something very, very simple. But everything, all important decisions rely on the pilot. Then we can go to the next group. You have some automation. You already have sensors. Most of the cars nowadays are here. And then there will be a pilot. We've taken some decisions. The decisions will be inputted in the computer, and then the computer will say, okay, it's good to go or not. That's road assistance, lane changes. It will tell you something. The computer will interact with you. The next will be, we just remove the pilot. And what I mean remove the pilot is like we take your inputs out of the equation and we leave all the decisions to the computer. You just enjoy the ride. And that's where we want to go in the car industry. And fairly fast. It's going fairly fast with all these systems. Now, if you take all these systems and put it in an unmanned aviation, that's what we're doing. We're just taking all these systems because this industry is progressing way faster than aviation is progressing right now. So we just basically making use of that and try to take all this in new instrumentation, put it in the UAMs or the UAVs, and try to make our urban air mobility. So now, once we do this similarity, what is really unmanned aviation? What if I tell you, and I'm going to take the liberty of share with you my personal opinion on this, that unmanned is a degree or a level, meaning that the more advanced the technology are managed, the more autonomous the aircraft becomes. And when I said an airplane is unmanned, it's because there is some technology in the aircraft that allows the airplane to fly by itself. You still have the pilot to do some inputs, but you still can have no aircraft control, no pilot input, and the aircraft will fly. Spacecraft, the first flight of the, correct me if I'm wrong, first flight of the space shuttle was fully autonomous, and same with the Buran. There was no one on board. And they were doing it perfectly fine. So it's a degree that we want to increase. When you arrive to fully autonomous, you are in this area, and when you are in remote piloted, you are in this area. You just have some level of automation, like controlling the altitude, controlling that you don't crash with anything. Those sensors give you some level of or some degree of autonomy. Anyway, in 100 years, we went from this to this. So we had pilots talking with traffic controller. We just introduced computers, but we still have this talk between pilots. There's a human telling another human what to do. Before, it used to be human tell human, and then the human acts. Now it's like human tell human, and the human tell the computer, and the computer acts. That's what we're doing nowadays. In the future, we just want to remove this component, and then computer will talk with computer, and they will act on their own. So we don't do human mistakes. So what's next after this? What can we do? It's basically to do this, put them together in communication. We just make them to talk by each other. And the next step will be artificial intelligence. It's more than just software core. It's something that can actually evolve as it goes by just doing software and coding on its own. So artificial intelligence is a big word. And all of you are thinking when we talk about AI, you think about ChatGPT, right? Basically, artificial intelligence is a set of software that learn from the data, recognize some patterns, and understand the language, and that's processing super fast, really, really fast. And ChatGPT is not really an artificial intelligence. It's a model. It's basically a generative pre-trained transformer. That's ChatGPT. And what it does is like it predicts the next question, the next word based on some training that costs millions of dollars to do, predicts what's the most statistically probable word that will come after the previous word based on the question that you asked. And that's why sometimes you ask something to ChatGPT and they say, oh, improve my code, and he make it worse. Right? Or you ask for some picture and the picture is nothing to do with what you imagine. So the good thing is allow you to perceive and think and act. They call it think and act, but it's basically a pre-trained energy. What we are looking at, or the scientists looking at, is general AI. And general AI means that the software doesn't need training. It will think like you and I. So how can we integrate this into the aircraft? Well, as I always picture it, if we put that AI in aviation, I always have if you have seen Interstellar movie, you have TARS. And TARS, the only thing it does is some basic controls, but he talks. He communicates with the pilot. And this is the important thing, because in an aircraft nowadays, we have hundreds and thousands of automations, a lot of instrumentation, and a lot of information that is displayed to the pilot. In a stress situation, we reverse back to basics. We reverse to our mother tongue, we reverse to things, is psychologists. So if we can make AI to talk with the pilot, and I like to say humanize the talking. We use a machine to make the communication with the pilot more human. And then the machine will talk with the pilot and say, oh, engine failure, or you have low hydraulics, low oil pressure, whatever, or what is happening. And then the machine will tell, we might have an engine failure. I suggest that we can actually shut down this. That will be your digital co-pilot. Many airlines are looking for this because, they can remove one pilot from the equation, which is cheaper. And obviously as well, another use for AI will be air traffic controlling totally automated. So we remove, as you saw before, the pilots, the air traffic controllers. We do all this through research, publications. Like basically, we try to investigate and try and error. And I'm going to jump quickly into research. The definition of research is a systematic and structured process of inquiring and observation and analysis, etc. That's the definition of research. And the ideal, and I remark ideal, aim of research is to generate new reliable knowledge, to improve human life, explore the unknown, right? To inform and to train future thinkers. So we need to help humanity to progress. That's research. Sadly, today's goals is filled with publication pressure. All the researchers, you are judged by not how good your publication is, but how many you have. And we talk about this, publish or perish, which is like, if you are not productive enough, you don't publish enough papers, you're not a good researcher. Citation chasings, the more citations you have, the more star you are. Not like going to my university, they had the stars of the university, the ones with more citations and more publications. But no one read their articles, no one read their papers. They don't know what he was talking about. And then you have funding-driven agendas, because if you say, I want to research in a new type of petrol engine, no one will give you money. Or even if you say, I want to research on, I don't know, nuclear energy for cars, no one will give you money. But if you say, I want to search in a new way of carbon fiber from windmill sustainable, you just put the word sustainable, the word green somewhere, and you will get funded, even if it doesn't make any sense. Because it's driven agenda, because it's what is 10 years, 15 years ago was everything related with lithium-ion batteries. Around 5 to 6 years ago, it was the hype of hydrogen. Everything that hydrogen contained was good to go. And of course, political and corporate influence, the governments. The governments are the ones who give the money and are the ones who dictate what you should actually research. And that's bad. In fact, maybe some of you know this man. This man is Peter Higgs. He predicted the particle in 1960, the Higgs particle, which is a particle that gives mass to other particles through an energy. And it was found in 2012. It was proven. And he received a Nobel Prize for it. This man, not long ago, he went public saying, I don't think I will have been regarded as productive enough nowadays, under nowadays standards. Because in today's academic climate, I will never have had the same kind of breakthrough that I had in the 60s when he was working for years in the same thing. And then he published 1 or 2 papers. Because modern system puts a high value on productivity, I probably wouldn't have even found a work. A Nobel Prize, with one of the physicists' discoveries more important of the century. So it makes you think. So what is this? Why is this happening? It's because nowadays universities are ranked in a list. Normally these are the biggest one. And this ranking depends on publications and citation. More papers, And citation, higher rankings, more prestige. More prestige, you get more students, you get more value. Also, you're more likely to receive funders if you are high ranked. And of course, the competition, international competition, I'm better than you. Okay, I'm better than this university. The thing is, like, the citations you normally publish through publishers who contain the journals where you publish. And these journals operate under paywalls or high paying wins. So I have to pay to publish my paper. But you as a public have to pay to download it, around $30. But if I want you to download it for free so I can have more citations, then I will also pay the journal an extra fee, which can be around $4,000 for making it open. So I pay a fee just to be member to access their database. Then I pay for publishing my paper, and then I pay again to make it public, all for the sake of having more citations. So these four main journals are called normally the academic publishing cartel, because these are the four biggest publishers, and then they dictate how everything is going to be made and how. And it's a bit sad because they transform the way of researching nowadays, but it's what it is. But there is not everything lost. There's some fighting against. We have some Robin Hoods that try to fight this cartel from time to time. And we have Aaron's work. He actually was a hacker, a very prolific, very good engineer, and he was a programmer that he co-founded the RSS 1.0, and he helped to code as well Reddit. And he was 100% pro access, free access to scientific papers. And he was famous for downloading millions of academic papers through MIT network, and then he got caught, and he was facing $35 million fine, even facing jail. So suddenly he ended his own life in 2013. And then we have Alexandra Elkavan. She was a neuroscience student from Kazakhstan, and she was studying with very economical efforts, very difficult for her. She realized that she couldn't access in papers to study and to progress because she had to pay and she didn't have money. So she created a Sci-Hub, which is a place where you can find papers for free. She's been chased and she's been trying to take him down because all the academic mafia is against her, because now you can find most of the papers that you can find in Elsevier, you can find them here for free. And now people, own researchers, are by their own will taking their paper to her website just to be shared with the public. So yeah, we have some people, but still, it's a very difficult to fight this tendency. So what is a researcher, right? One who conducts systematic research or investigation, right? The work derives from the old friends to search again. So even the word pushes to keep searching. And a researcher was basically someone that needs to be all the time researching, right? Curiosity, finding patterns. You need to realize what is something new that you want to discover. And I want to just about to finish asking you a couple of questions. Who is, or who you think is, the best researcher on the planet? What's the group of people that are the best researchers on the planet? These are the best researchers on the planet. Because they're curious, they're all the time testing. They're testing an error, they seek, they try to find. And this is where we should go back. We should go back there, and we should stay curious, we should stay bold. Don't wait for permission to explore what passions you. So research is not just for academia, it's a way of seeing the world. So please, let's reclaim that instinct, discover, understand, and just did what we did when we were kids. Thank you very much.
Patxi, thank you for your pragmatic, remarkable keynote at our symposium. It was such a great pleasure to host you. Thank you. Thank you.
I would like to thank Vladimir and Patxi for the great talk. Thank you very much. Thank you very much for coming. Thank you very much that you accepted my invitation. Great honor to have you. And I'm very glad also that you are here. Well, because I didn't know what you were about to talk, and now I don't know how to start, honestly, because I thought I will say some things, but because I'm irrational, maybe I will start irrationally. So I'm taking a phrase from Hermes Trismegistus, saying that as above, so below, and I'm paraphrasing it as that as within, so without. So both Vladimir and Patxi actually touched that point in their specific area of expertise. So it's it is above, it's the same below. There is an analogy, and as within, so without. So whatever it's within you, it's the same outside. The question comes to if we apply what we believe. I totally agree with you, Patxi, saying that we have to behave like children. It's everything comes to that. Even from the religious point of view, in our religion, in Greek religion, Greek Orthodox religion, Jesus Christ said that let the children come to me, and he meant everybody that have the heart of the children, of a child, and that's the important thing. Now, theoretically, it's there. Practically, who does it? And that's the question. You said about research and the academic thing, and I totally agree with you, and we discussed that, I think, a lot of hours in Gothenburg. But, yes, that's it, but who does it? Who is willing to break this outside and not just it's just theory? It's just, yes, it's a good thing, it's, it's romantic maybe sometimes, but what's happened? I didn't know about those guys. For example, this guy that you said that he committed suicide. And he committed suicide because he couldn't stand this pressure. And it really worth it? I think it does. And at some point of your life, I think you have to decide if you go with the mainstream or you go out of this mainstream. And actually go to the stream of life, to go to this stream that actually you will enjoy life. And at the point is that you have to make a decision, and the decision is yours. If you decide to go mainstream, and be there till you realize that what we're living right now is an illusion. If we put the electromagnetic spectrum in a linear form, it's maybe 40 million kilometers long. What we can see, it's a window of 3 centimeters. We are blind. I've talked to you a lot of times. I'm telling you this again. We are totally blind. We don't see anything. So it's a pity that when somebody comes and say, look, I saw it, and when someone says, I saw it, this is true, I totally laugh, because you don't see nothing, because you are blind. It's arrogant, it's not humble to say that I see it, because it's, you see it out of stupidity. And there are a lot of stupid people, especially in academia, especially in universities, because they are thinking that they have a PhD or they have I don't know what, and they suddenly become close to God. In order to become God, you have to try, really try. And nobody gives you this thing. Nobody says that now you are God. There is not a committee saying that we are God. You have to act and be present and practice what you believe. So, as above, yes, it's so below. So whatever it's in the universe, as Vladimir showed us, that's also the cosmos within us. And to answer also the Thomas question yesterday. So yes, our perception creates our world, as Patxi mentioned yesterday. Yes, that's it's true. And if we stay at our perception, actually, it's a pity, because our perception, it's not the reality. It's an illusion. We are confined in this space. We cannot go anywhere because nobody trusts us. We have to think about it. The universe doesn't trust us that if we left alone and we can do a lot of things, that we don't ruin everything. So they confine us in this small pay dot, as Carl Sagan said, and Vladimir, a quote, what Vladimir said as well. We are here. This is our spacecraft. This is we have to see what we are going to do here. Because we are here for a reason, and we have to find the reason. I'm not telling you what the reason is. You have to find your own reason. You have to do your own work. You have the responsibility to do your own work. If you don't do it, as I said yesterday, you're just travelers. You are here for holidays. You have to realize that this is not the case. So, what we are really a body, a mind, or we are aware that behind it's both. All philosophical questions. I think I'm not here to answer any philosophical questions because, honestly, I don't care to answer any philosophical questions. You can refer to Aristotle. You can refer to Plato. You can refer to anyone. There are answers there. The bottom line is that you have to do something. I think humans, we are the information is out there. Use ChatGPT to get information. There is no need anywhere now to go to a library to study books. The info is there. Now it's time to apply. Now it's time to become engineers. Don't stay to be physicists, theoretical physicists. You have to become engineers. You have to do something. You just stay and most people quoting things that I've heard. Most people quoting other people, wise people, maybe religious prototypes, like I don't know, whatever you believe. But at the end, you have to do whatever it needs to be done in order to expand as a human being. Well, there are some steps that you have to follow as an inner astronaut journey. You have to recognize that you are not just this body. You have to detach from your ego and emotion, a very difficult thing to do, because you think that you are someone very important. You are not. Nobody is, not even Earth is important. Billions and billions of stars, and you think you're important. And I'm saying that because in order for a person to expand mentally and spiritually, first he must realize, I think the first step is to realize that how small he is. And then he can go to the next step, understand his greatness, out of his smallness. I don't know how easy to grasp this concept is, but this is the way to do it. This is the only way to do it, is that you have to understand the smallness. Most people think that, do you know what I can do? I think you cannot do nothing because you don't know if you cannot control anything. You cannot control your heart, you cannot control your bladder, you cannot control your breathing. Nothing is controlled from you. So it's like universe or God said, okay, I will put you in autopilot because I don't trust you. You have an AI inside you because I don't trust you. The only thing that you can do is just manage some of the system. And we don't even doing that correctly. Just manage your thoughts. We don't do that correctly. We cannot manage our thoughts. Nothing. We cannot manage our acts. Why did you do that? Because I don't know. You ask a person, why did you do that? I said, I don't know. You don't know. It's just asking a pilot, why did you land when you see that it's foggy? I don't know. But we crashed. Okay. So the universe said, okay, let's put you on autopilot, AI, breathing, it's my call, beating of the heart, my call, bladder control, my call, don't control anything. I will tell you when to go to the bathroom. Small babies. I'm just giving you examples of why we are small babies. Small babies saying, okay, now I discovered. Yes, it's a first step, but you have to realize first that you are a small baby. So when you talk to someone, when you're dealing with someone, you have to realize that he's a small baby. Just say, okay, I'm not expecting something better of him because he's a small baby. Don't keep grudges. Don't say, don't keep it in yourself. Okay? Many times, recently, someone told me that he doesn't talk to me because of something that I did 4 years ago that I didn't even remember. And I didn't do anything. I mean, he perceived it in the wrong way. For 4 years, he's holding that into his heart, and he didn't tell me. So I didn't know. So my question is that he's taking a poison. Who's killing? He's killing me, or he's killing himself? I think he's killing himself. If you take and you have any grudges to anyone, just go outside and tell him, I don't feel, it's not right. Don't keep it within yourself. Simple things like that. He cannot do something better than what he knows. I'm not saying that I'm doing it. I'm also in this position. I'm here as well. Everybody's here. We are playing with the same rules. We are playing with gravity. We are playing with the rain and that's it. That's the atmospheric conditions. That's it. We are growing and etc. But at the end, it's what kind of relationship you like to have within yourself and with others. We have to take a giant step towards this. We have to diminish our ego. And we are so emotional sometimes. Oh, it's a pity. Nothing is a pity. Who is to say that it's a pity? I don't understand. I cannot understand. It's a pity. It's a pity of what? He failed the exams. It's a pity. Why it's a pity? You don't know what life brings you. Sometimes people say, he got cancer, for example. It's a pity. Why? 30 years, give or take. Okay. I sound harsh. Yes, grow up. Mature. This is it. It's a pity for whom? It's a competition. I live longer, it's better. It's how you live. Making more papers is better. It's not. You can make one paper and get a Nobel Prize. Not I found, it's something, Nobel Prize is something, but I'm just saying. Because, okay, it's a prize. Then in your tomb, you will say, he had a Nobel Prize. So you go to your judge and say, look, I have a very nice place in paradise because I get a Nobel Prize. And with this Nobel Prize, I get also 1 million euros, something like that. Huh? So let me in. I don't think universe or God or anyone will care about money. Maybe it depends on the conversion rate, but I don't know. No. If they have a war in the stellar or whatever, I don't know. Expansion of awareness. Yes, I'm just saying things that expansion of awareness, we have to be aware of what? We have to be aware that everything is an illusion. Everything is an illusion. Everything. If you realize that, your life will become better in practice. So when you fly, and it's a bumpy ride, which I totally enjoy it, because otherwise it's boring, very. Relax. Don't be afraid. People died in order for this machine that we don't know how it's flying. we kind of know. There are some principles. It's flying, and that's good. Don't worry. There are millions of ways to die. So enjoy it. It's something very nice. It's easy to do it, but you have to start with something. So expansion of awareness, you have to be aware that you are living you're taking your life very seriously. Very seriously. It's like kids counting the stars. I don't know if ένα παιδί μετράει τα άστρα. Not Demis. Yes, the little prisons. Little priest. Sorry, yes, the little priest that this guy was. It was the guy that he was very busy of counting stars, and he was very serious about his job. And maybe you've read the book, maybe you've seen the movie, and you laugh about it. Most of the people doing the same thing. What are you doing? I'm working. Don't disturb me. I'm very serious. And maybe you can fire, and the company will bankrupt. And what happens then? You are very serious with everything. Also about raising children, very serious. Very serious. When we are raising children, we are very serious about it. And we forgot that the children are coming not from us, but through us. We have to be humble. They are not belonging to us. They belong to themselves. We are here to do whatever we need to do. I'm not giving advice. I mean, it's not my position to give any advice right now. It's through us, not I've made this. No, you cannot go to the toilet by yourself. You made this kid. How? Animals do it. You enjoy the moment. Nothing happened. You don't have any control of it. Okay? We are all grown up, so most of us know how children are made. Okay? So there are over 15. They should know. Integration, living as a whole being. Yes, whole being. You have to be. You have to be. Just be. I was in the Honey Mountain many, many times, and we had a lot of discussions there, amazing discussions with people that are open-minded, because in every profession, as also I consider mine to be a profession, there are closed-minded people. And when we touch the notion of God, which is an amazing, touching notion in every religion, because it's within us. I don't know how you name it. Nobody cares how you name it. It is what it is. They call it love. And when they say what God is, they say it just is. It's a be. That's it. And of course you cannot describe it, because you are living in the moment. You are there. Not in the past, not in the future. Past is gone. Future you don't know. You are there. You are here right now. And maybe you've heard that before, many, many times, and okay, but we have to do something about it. I know that everyday life is very, very serious, and you have a lot of problems to pay bills, to cook, to clean. So many important things. Very important things. To raise your children, to find parking spaces, to drive through Naoussa in these roads. It's very important, extremely dangerous. And but I found out that whatever you do in your everyday life, if you have your mind connected to God, it gives something different. In any God, really any God. I think God will not be insulted if you call it Kostas on Dimitris. If he will be insulted, it will not be God. Because God is love. That's it. And love is universal. If it's not love, then it's not God. But not love in the sense that everybody thinks emotionally. Love like you have a child in front of you that you need to grow, and sometimes you have to be hard, and sometimes you have to hug, and you play with him. It's not like, I would like a car, please give me car, and I pray for a car, and you give a car, and then you are a good God. And then when you don't have the car, you are a bad God. This is not how it goes. Please give me health. You gave me health, I'm a good, you are good. My praise was heard because I'm a good person. Then someone behind me is dying from cancer. He was bad. Really? He was bad because he was dying from cancer? He was a bad person? What he did? I mean, you have to clarify those points. So when you're doing an errand, instead of be anxious, okay, give some love in your life, some inspiring, something different. Again, when I was in the Holy Mountain, I was helping, and it was so, it was a humility because I had a PhD, I had a master's in aerospace engineering, and I was so important, and I also making some money, a lot of money. And one of the monks said here that we have to make the beds. And of course I'm ironic because I'm always making the bed. I'm a very good boy. I've learned that from very early age. So, no, from early age. Labrini came later. Yes, I was ready. I've born ready. So, and as we were talking, he said that, do you know that also when I'm making a bed, I'm praying? So it's not the making of the bed. It's what you do while you're making your bed, where your mind is occupied with. If it's occupied with stupidity, whatever you do, it's stupid. So if you raise your children and your mind is how I will pay the bill, or if the moussaka is ready, or I don't know what you are thinking, you are not doing a good job. If you are working and you are not there, you are not doing a good job. You have to have your mind in the essence of what is happening. Are you able to do that? Completely. This is the only thing that you have to do. You have to manage your thoughts. If you don't manage your thoughts, that's it. If you are not capable of doing that, now, we are not just a traveler through space, we are space experiencing itself. So if we knew yourself completely, what we will still fear, I think we'll fear nothing. Why we fear? What is the worst fear, you think? Tell me one fear. Come on, Katerina, tell me, what is the fear? Of death. Yeah. Huh? Okay. Nice. That's a first step. So you know that it's going to happen. It will not be a surprise. Okay, perfect. Yeah.
Yeah, I was just saying, dying, I'm not afraid of death because I know it would happen. But what I'm afraid is dying without having the time to finish all that I still want to do. I have lots of ideas, projects that I want to complete it before dying. But of course, I'm not the one who decides.
Oh, perfect. That's a very nice step. You don't decide. Since you didn't decide that you were born like 35 years ago, 20, sorry, take, leave or take, I mean. So you didn't decide that. So you don't decide when you leave. That's good. So there is nothing to fear about. Nothing. Not even if you are anxious of what you are going to complete. You are going to complete when something feels that you are complete your journey here. This is decided for you. That's it. The only thing that you have to do is to enjoy it. Someone else decides for you. Something else decides for you. Because we are not alone. That's definite. We are not alone. If we believe that we are alone, well, so we believe that all this vastness, just we alone, and I'm not speaking about other human beings or other creatures. We are not just in the universe is within us, it's a starting point. If someone doesn't want to go through the educational road path to be educated, to be an astronaut, or to be an astrophysicist, or to be an engineer, or whatever, he can also explore things within himself. So through philosophy and spiritual science, we can unlock latent powers of consciousness. Yes, why not? But I would like to stand before finishing. All right. Before finishing, I would like to stand to the Greek word of philosophy. Philosophy, I think it's an underestimated word. We're not using it correctly. Because in the Greek mentality right now, philosopher means that someone just speaks, sitting maybe down on a tree, under a tree, and doing nothing and drinking coffee. Philosophy is not about that. Philosophy is to understand, without even maybe sometimes rationalizing it, what is within you and you apply to everyday life. This is philosophy. What I've shared with you right now, many of you know me for some days, maybe some years, most of you, but I know that whatever I'm saying, and maybe I've said too little for other reasons, is that sometimes I don't rationalize it because there is no need to rationalize anything. This is who I am, and this is what I applied. So if I don't like something, and it's against my philosophy, then I'm doing something else. I'm not attached to anything. That's it. Because I'm not saying that you have to do the same thing. I'm just saying that this is what I perceive of life, and this is what I do. So you perceive your own things and do what you believe is right. But you have to do something. I think I would like to left you with this note. To go to space, there were people that did something that they believed. They didn't start in a chair saying, I would like to go to space, and they did nothing. Patxi mentioned some people that also they wear wings and fly from monasteries, and they did something. Back in the day, they considered to be crazy. Remember? But this is how aviation evolved, and now you are flying. It's small steps that takes you somewhere. And since we are in Greece, and we are most here Christian Orthodox, I would like to say something else. Also, Jesus Christ considered to be crazy, totally crazy. Believe it or not, even if it's a fairy tale, I like this fairy tale. I prefer this fairy tale than TikTok videos. I like this fairy tale than people publishing papers think that there's something special. I prefer this fairy tale. A person that believes for his own life, for his own beliefs, and he considered crazy. I like this craziness. This craziness is healthy. Very healthy. Crucified, 30 years more, 30 years less, who cares? We still talk about him. Everybody. Everybody tries to research him, to find who he was. Everybody believes in him. If he will come back, he's not crazy, that crazy. But I totally believe that if he comes back, again he will be crucified. One way or the other. There are a lot of people on Facebook commenting that he will be crucified for real, because he will be crazy. And I think also in the Russian not religion. There are a lot of Russian people, Christian Orthodox, that they have this way of asceticism. They show to be Christos Alos, crazy. They perform this craziness to become like Jesus Christ. So it's a form of asceticism. So this actually is very close to what he believed. So that also gives you another point of, you have to be a little crazy, depending on how you like to be, in order to make a point to your life. I don't think someone came here just to say, look, I'm God. He didn't care. He knew who he was. You have to know who you are. He came here just because he would like to be here for a certain period of time, and he did whatever he believed it's right. And then he left. That's it. We went to the tomb yesterday. Nobody knows. Nobody who was in this tomb. Nobody. Oh, it's a tomb. That's it. So I leave you with this happy note that everybody is going to die. And I wish you a very happy life. And I think now it's time for Chrysostomos or Thomai. You would like to thank everybody? Okay. No, of course you can. You take the microphone. Huh? You would like to thank me?
Okay.
No, don't thank me.
Okay, we would like to thank Nikolaos. He promises to give us some thoughts about our inner cosmos, and we think once more he has inspired us a lot. Thank you, Nikolaos. Thank you, Patxi. Thank you, Vladimir.
Okay, so we have one more session left. This is the Q&A session, which is the final time frame for our fourth symposium. But before we move on with your questions and inquiries, including our live stream participants, we are currently being live streamed as well, and we thank you for your interaction and participation. On behalf of the Scientific Association, and as a very small token of gratitude for all three of you coming to Naoussa and truly sharing amazing and wonderful experiences in a very authentic and sincere manner, I would like to just provide you with a plaque of appreciation and a small gift from us, along with informational material about the city of Naoussa, which was provided by the municipality of the heroic city of Naoussa. So first of all, I would like to invite the presidents, the association's president, Evgenia Noidou, and Vladimir Pletser, so she can provide the plaque.
Also, I would like to say something. It was also very nice from the municipality of Naoussa that he was here and honored this occasion. Thank you very much for not being here.
Should I mention that also through the microphone, because it was not mentioned?
Yeah. Would you like me to?
No, that's fine. Yeah. So beyond the bags, would like to thank representatives from the municipality for being present and honoring us yesterday and today and during the past three symposia as well. And onon noito, we say in Greek, so whoever got the message got the message. Okay. So,
Thank you for being here. It's an honor to be here.
yes, λίγο να το φωτογραφεί. Τις τσάντες? The bags, please. Yeah. No, please. Okay. Thank you to our president. Now I would like to invite our treasurer, so who keeps our finances in a good position, Mr. Thomasitsios, so he can provide the plaque to Patxi Acero. bags. Yeah. And finally, our board member, Georgia Oslianiti, to give the plaque to Nikolaos Divinis. Λίγο, Γεριά, λίγο πιο, λίγο, ελάτε λίγο πιο εδώ, λίγο κι άλλο κι άλλο, εκεί, λίγο γωνία. It's an honor for the city of Naoussa. That's what Georgia said. Okay, so I would like to invite the speakers to take their position in the panel so we can conclude with our questions and answers.
So before we move on to our, again, any inquiries we have from the audience or any inquiries from our live stream participants, please allow me to just recap what happened yesterday and today. Okay. So we started yesterday with expanding our horizons. I think all three speakers took us to an amazing journey in their own personal endeavors and preferences and inquiries. And today, from this journey of expanding our horizon, what is a journey? What is the meaning of a journey if it's not meaningful and eventually transformational? Otherwise, as Nikolaos mentioned as well, we are just tourists, just spending our time for whatever reason. So today's session was all about transformation. We expand our horizons yesterday, and the meaning of a journey, even going to space, it's transforming your own self. Because life, after all, should be all about transformation and evolution, constant, no matter what. That's how the universe actually works. So we touched upon the three interconnected elements. We started with space research. So space research challenges us to rethink our understanding of the universe and our place within it. Then we move on to research on Earth, which deepens our knowledge of our natural resources, ecosystems, and our relationship within the environment. And finally, inner research. It fosters self-awareness and the ability to transcend personal limitations. So, Vladimir, you definitely took us to an amazing journey. In microgravity, two planets, the universe, this vastness that it's just inconceivable. And I think that relates, Nikolaos, to what you said. This vastness makes us feel very small, but still very important part of a greater puzzle. And it's a very delicate balance for all of us to achieve. It may take many lifetimes to realize that. So, Vladimir, you inquired, what sacrifices are we willing to make in our quest to conquer the stars? What sacrifices? Financial, psychological. So, through space research, you revealed that maybe humanity's next step is not merely expanding into the cosmos, but maybe redefining life on Earth itself, right? But one thing we would like to share with you is that your passion, the excitement and joy about what you do, it's definitely motivating. And we hope, on behalf of all of us, that you maintain this energy, this excitement, this unbelievable feeling as you described the parabolic flight yesterday. And thank you for being with us. Just your commitment to the unknown and expanding those limits is definitely very inspiring. Patxi, you challenge us to ask ourselves, do we protect Earth or just our own small microcosmos that we all live in? That's a very important question. Your expertise in AI, artificial intelligence, in innovation, your honest approach to sustainability, and your provoking thoughts about the contemporary status of research. And for yourself as a young and aspiring research engineer, it's definitely a source of inspiration to younger people. We have adolescents in the audience, that the status that you presented and your personal stances can be truly motivating to them. So your dedication to aviation research, to combining research with impactful elements that is helpful to society, it's also very inspiring as well. So we hope that you find your journey in academia, in research, and you take a stance on what you shared with us these past 2 days. So thank you so much. Nikolaos, you definitely provoked very deep reflection on so many different elements. You challenge us to think whether we can truly explore the universe without first understanding ourselves. Your exploration of consciousness always urges us to realize that the ultimate frontier is not among the stars, but within. It was not just a philosophical approach, as you shared at the end of your speech today, what philosophy is all about. Because philosophy is transferring what you know into everyday life. It's not just being a theoretical physicist, as you repeatedly mentioned, but being an engineer, and engineering your own life in a practical and meaningful manner. So your commitment to humanity and life itself in this authentic, sincere, and selfless manner, it's moving, to say the least, but it's also very thought-provoking to not just enjoy the journey, but transform our own lives. So thank you as well. What we all discussed yesterday for all three of you, coming from space, Earth, and the inner self, is that you all had your own individual stances of things. In the debate yesterday, you may have disagreed, and that's very fruitful. That's how evolution happens. But what we all discussed is that at the end, there was a unified manner that you talked about space, Earth, and the inner self. So there was a nice interconnection, even through individual stances and disagreement. And this unified way was a source of inspiration to all of us. So we cannot thank you enough for being sincere, being authentic, being selfless about what you shared, and in a unified manner. So thank you all. So now let's open it up to questions. We have plenty of time. We have some questions already from the live stream, but we'll pass the microphone to any questions you might have for our speakers.
Okay. I would like to say some thoughts. For what Judge Chrysostomo said. Nikolaos said to his speech that we must be humble, and I'm thinking that when you think the vastness of the space, as Vladimir explained, it's a way to be humble. The one helps the other. The research on the space maybe help us to be better in ourselves, be humble, and to know that we are not something that we believe we are something very, very big or something. We are a dust in this vastness. This is what I want to say. And another thought that came to me, now that we are seeing space and inner self, I thought that how stars and galaxies are arranged, the same things is arranged in the microcosmos. How atoms are together with the electrons orbiting around. It's like a planetary system that has the sun, and so we have a similarity how the space and the microcosmos is. And my thought is that this is with inner self. This comes to inner self. This is what I want to say for all of the things I heard today. Thank you.
Thank you. Any other question from the audience?
Hello. First of all, congratulations to all three of you. It was really interesting and very enjoyable. also yesterday and today, and I would like to ask you, all the three of you, for your personal opinion, what do you believe is the purpose of the human beings here on Earth? That's the question. Because, you know, it's three different topics, so I like to hear everything.
Okay. Thanks for the question, philosophical question. First of all, let me start by that if I will know the answer, I won't be a human being. So there's no answer from my part that it's gonna satisfy you. But I can try to give you my personal perception or opinion of why we're here. I think we are here not to find the answer to what we are here, but to explore. We are sailors, right? We are, as he mentioned, we are in a spacecraft, you know, going around the cosmos is our ship, and then human beings from all the history, we tend to explore. We want to know the unknown. So we are here to just do that, learn the unknown, whether it's going to discover another continent, going to discover another planet, or going to discover something about yourself, which, believe it or not, I think is nowadays the most difficult part, that we don't even know ourselves anymore. So I think we're here to learn, and that should be the purpose of us.
That was this is a very good question, of course, but it's more related to philosophical or religious background. I may answer in two steps. The first step, when I was a younger man, I'm not a kid anymore, but let's say a young man, I was thinking that the purpose of life was actually to prepare a better world for our children, for the next generation. And I thought, well, that was, you know, you have a goal and you have a purpose in a sense that you would, you know, have children and you would prepare them, you would change the world, you would try to improve the world, and you would prepare it for your children to make it better for them, and then hoping that they would continue and do the same thing. So, you know, improving the earth, you know, bettering the world as well. Then I realized, well, it's very ambitious because changing the world, of course, very difficult. So you can do, what you can do is changing yourself, trying to change your environment, your you know, your friends, your wife, or if they are ever possible. But let's say, try to improve, or you letting be changed by your wife, of course, let's put it that way. So so that was of course, well, I realized that when I grew up and when I was a bit, I don't know wise or what, but that was a good idea, but let's say it was not sufficient or not really practical, not really realistic. Then I thought, well, okay, researching is something that I always did also, even when I was a child, when I was a baby. I like very much that picture that you show at the end of your talk. These are the great researchers, of course. And I try to keep this element of curiosity, because this is what is driving the research. Then I came back to that when I was a bit older, let's say, and say, no, this is really what is important. Of course, family, children, and so on, very important. That's probably priority number one on top of the list. But then priority number two, but of course, when your kids grow up, they leave the house, okay, you can switch maybe to priority number two. Priority number two is learning, discovering, researching, asking questions, pushing the boundaries, go further in all directions. It could, for me, space, because this is what is my passion, but there are other domains as well where you can push. I mean, exploring the Earth itself, the ocean. We don't know much about the ocean. It was said yesterday also, we know only a few % of what is under the surface of the water. And this is, although it's still part of our spaceship Earth, of our planet. So research in all directions, and I would like to contradict a little bit also what my friend Nikolaos said, because I did not agree with him in one of his statements that he gave today. It's better to be an engineer than to be a theoretical physicist. I fully, completely disagree. It's much more important to be a theoretical physicist. Try to discover new things. An engineer, everybody can be an engineer. You build something. It's important as well, but you build something, you move, you move the technical progress, but it's more important to discover new things, new fields. So I think that's the purpose of life for a human being, men and women, basically. Thank you.
Thank you for disagreeing. After 3 beers, I think we'll agree again. Maybe 5. More than 3, okay. It's important, of course. I don't think anyone can be an engineer. So you can build a thing, for example, an airplane, and this airplane must not fall from the sky. So it's important also to be a good engineer. And of course, when I mentioned, just to clarify that about the theoretical physicist, if you stay to the theory without applying it, there is no purpose in life. I mean, you have to apply this theory somehow. Knowledge is enough. Okay. I think we have the knowledge that we need right now, and we don't use it. That's my. We need more. Okay, we disagree. We agree to disagree. Yes, but we disagree. Well, I believe that Earth is a giant hospital. So either you come here and stay here to be a patient or a doctor. You decide. This is what I believe. So either you stay and you say that you are a patient. Now you may have a slight fever, you have just a small cold, you can have cancer, multiple cancers. Everybody has something, or you start becoming a doctor. Maybe healing yourself first, of course, and then I don't know, whatever you decide. And that's also because we are confined, because we can contaminate a lot of things. You know, we are extremely, I believe, we can contaminate a lot of people, and you can see that also in your families. It takes one person to contaminate everybody. Just if this person would say something, can we contaminate the whole families? The whole family will split apart. So the purpose of life, I think the purpose of life for me is to heal yourself. We have the knowledge to heal ourselves. The knowledge is 2,000, 3,000 years ago. We just, we may make the knowledge more in today's life, but it doesn't. The knowledge is there for me. We need to apply this knowledge at some point.
Thank you. Thank you.
So we'll follow with some questions from the live stream chat. That's a question for Patxi, but again, any speaker can take a stance on this. So, Patxi, you talked about developing systems that actually substitute human interaction. So the question is, what's the main reason for doing this?
Okay. I think I was a bit confused. I didn't actually say substitute human interaction. I wanted to express that what is intended is to simulate human interaction. Okay. So we trying to use machine to simulate another human for the sake of having the real human that is actually in the cockpit in this case, to not feel alone, to feel more comfortable in terms of stressful situations. We always react much better with another human. But sometimes we also have conflicts with another humans. Or sometimes we do things and we believe that we are doing the correct thing, but we are doing the wrong one with respect to the other because we don't communicate enough. So in this case, the system that is being researched in several fields within aviation particularly is to try to take a machine that has both knowledge of what is happening in the aircraft, all the inputs are being given to the aircraft, and as well an outside view of the other real person that you have next to you. So the system is a holistic perception of both exterior and interior ways. So the idea is to, of course there is an economical purpose of it, which is reducing the operational cost of any machine, so taking away the human factor, reducing the pilots, less money in flight, but also reducing the human error. You get surprised that 75% of the aircraft accidents are due to human error. Most likely, the one that we saw in Air India is being speculated. I'm gonna remark speculated that is due to human error, but we will see what the aircraft investigation says. So this system is trying to make aviation more safe by eliminating that error, but without removing the human completely. We want to help the human. We want to make sure that you will have a smoother interaction with the machine, because the machine are getting smarter and smarter, but we're starting to lose track, and we're starting to be unable to communicate in a smooth manner with the machine. So AI offers a door to smoother that transition and being able to communicate in a better way.
Thank you. Thank you, Patxi. Absolutely.
Thank you. Yeah, very, very correctly. I would like to just take one example. In astronautics, in the very early years of the astronautics, or early 60s, when the American NASA was building the first Mercury capsule, they called it a capsule. Then they recruit the astronaut, and the astronaut were all test pilot, and they fight with the NASA management, say, no, we don't want to fly in a capsule. We want to fly in a spacecraft, which means that being pilot, they wanted to stay in control of piloting the capsule, which was not a capsule, but a spacecraft. Eventually, NASA understood, and NASA agreed to this approach. So the pilots were in charge of flying, even if most of the flight were done automatically, controlled from ground and so on, but the human was still in the loop. Human in the loop is something, a very important concept as well. You mentioned, for example, some of the helicopter or this huge drone that can fly autonomously or remotely controlled. I would not feel safe if a human was not in the loop. When a plane lands automatically, I'm still happy that there is a pilot in the cockpit that could take over at any moment, because I don't trust the machine completely. I don't trust, I mean, you talk about human error. Okay, sure, that's certainly true. It happens a lot. You mentioned 75%, good. But it could happen also, software, you could have a glitch. Software could be disturbed by some radiation or some whatever external effect. It could be hacked. It could be hacked by malevolent people. And if you do not keep a human in the loop, it becomes very, very touchy, very dangerous. So safety, I still believe, are in hands of humans.
I want to add something regarding that, because even when I teach human performance and limitation in the pilots, we say 75%, this is the statistical number, but again I say that the other 15%, 5% is weather, all the other is again human error. It's ATC, it's human error. The electronic systems is made by humans, it's human error. And the act that you said, by humans, it's again a human error, let's put it. So the interaction of humans is always there. It's 95%, and I totally agree that I wouldn't feel safe, even myself, saying that I would like to have a pilot in the cockpit, and not only one. I would like to have two pilots, because I know that maybe people from the school in Denmark, they listen to us that are becoming a pilot, and I'm saying that, and I would like to clarify that we have to have pilots, because they have to have control. They need help. Yes, if we can provide help from AI, yes, it's great. It's great, but we have to have the management as humans, and this is what I would like to add. Patxi.
I just want to make a comment on both of your comments. What you just said was the goal of the research. It's going to take a lot of years, but your approach is a bit perception with your current mind, which is perfectly fine, and somehow I agree with you. But remember when we started with the cars, and the cars started to be in our fields, everyone was like, I'm not going to go on top of something that can explode below my ass, because I have a fuel of tank that is explosive, and it's very dangerous. I don't feel safe. I don't want to ride a car that also smokes at the back and is making thousands of explosions per second. And now we ride perfectly fine, feeling extremely safe. Because the technology evolved, so the mind of the society evolves when it gets used to it. So at some point, our AI is right now, and our systems are like those cars back in the days. At some point, I don't know when, this technology will evolve such that we will get this general AI, which will be no longer a set of codes, because it's true. You can get flips of bit due to cosmic radiation. You can get glitches in the software. So you can have a pilot that have a bad day and decide to crash the aircraft, right? So it's true. So at the end of the day, I don't think it's going to happen instantaneously, and this is a open debate, and it's a heated debate in the community. But in my perception, at some point, society will evolve to the point that general AI, which I remark we haven't achieved yet, will be so common among us that we will be totally used to them. And you will end up feeling safe around it, and it will be part of the ecosystem. It will be part of the things. But I totally agree that currently right now, also myself, I want to have two pilots behind it because it's not safe enough. I'm myself a pilot, and I always, sometimes when I do fly, I normally call a friend of mine or anyone else because I feel safer flying with someone else, and I enjoy more the flight having someone else. So yeah, that's it.
I would like quickly to answer also to respond to some argument. Your argument that the car, in the early days, people didn't want to sit on top of a tank of fuel that could explode and so on. Okay, but this is hardware. AI is software. Software you do not control. I mean, software, anybody can hack it. It could have a glitch. It could be disturbed by radiation. You have no control on that. Fuel tank or exhaust pipe cannot be hacked. It's hardware. Once you get all the safety there, it's okay. It should be okay. Yeah. Okay.
Today actually is a Q&A. It's not interactive debate, right?
We are not debating. We're debating in philosophical questions, which are more serious. Now it's a joke. So I would like to say that it's also something regarding the regulations about being a pilot. So even if AI is involved and we will move to one pilot, someone should be in front of the cockpit, even if as a transition. So what happens? How we train pilots? Right now we have two pilots and one pilot trains the other, and always we are current to have captains. If we stop having captains in the cockpit, how these first officers will become captains? So I think we have a long way to go, or we have to find a way to have people inside the cockpit, experienced people, in order to manage AI till after maybe generations. Because I agree, we don't know. Maybe after generations, people will be very confident and comfortable flying with something that there is nobody inside the aircraft. So this is just to add. If you like to debate.
So, to our next question, we talked a lot about frontiers. That was the theme of the fourth symposium. Frontiers, expanding our boundaries, go beyond our limits. And again, Vladimir, yesterday you saw the space, you demonstrated the space station, and you said there are no boundaries. I mean, in terms of where you come from, everybody is a unity. So what does it actually means to be boundless? What does it mean to be free? This is actually the question. What does it mean to be free or boundless? So this is, anybody can take this question. I mean, it's...
What do you want me to say? I mean, what's the definition of freedom? We are not free, obviously, like Nikolaos said at some point. Well, up to a certain point, but okay. There are certain degree of freedom. I mean, like in mechanics, of course, we have several degrees of freedom. But here also, it's boundless, but still within some sort of boundary, I would say. it's true that you do not see political border from space. You see natural borders. You see the ocean, you see the rivers, you see the edge of the continent and so on. These are natural borders. Whether you are free within these natural borders, normally you should be able to be free. You should be able to express yourself, to think what you want, to conduct your life the way you want within ethical boundaries. But again, you're not completely free because you have to answer to certain boundaries that are imposed to you by the society or by yourself. Ethics basically is something that you learn, or even which is innate. You don't need to learn certain aspect of ethics because you feel that it's not correct, for example, if you have a child, to abuse a child or to molest a child. It's ethically, it's innate to you that you shouldn't do things like that. But still, it still restricts your freedom. So I remember hearing something when I was young as well, that your freedom ends when somebody else's freedom begins, exactly. So there's a border that you fix to yourself, or the society fix yourself. So I believe in freedom, but limited, if I may put it like that.
Patxi?
Yeah, so I agree more or less with what you said. In terms of like the boundaries, we shouldn't have these political boundaries that avoid us to progress. But if we normally think like we have, or we are a species that seek knowledge, and we want to just increase our knowledge about the natural world, how to go forward, we can try to see that knowledge as a glass of water that you want to fill up, right? So the more water you have, the more knowledge we gain, and our life and our society and our species, what we actually do is just trying to fill up that glass more and more. Now the glass is a boundary. The glass is what makes the knowledge to go up. So if you pour the water, which is knowledge, on the table, you don't get any knowledge. Everything is split over and spill over, and you don't get the knowledge that increases. So we need a little bit of boundaries to address this in the correct direction, because otherwise we will be too spread around that we won't be able to focus and progress forward. So a little bit of boundaries are necessary. Being boundaryless will be, in my personal point of view, negative, because we won't focus in what is important to gain the knowledge. Taking as an example this glass as an allegory. Yeah.
Nikolaos?
Imagine that we are in a cradle, so we are protected by help me out.
Barriers.
Not barriers.
Bars.
With bars in the cradle. So we stay inside because if confined, because if we are free and go outside, then we may fall and hurt ourselves. We are not ready to go outside. So nature protects us. Not because nature doesn't want us to be free, but wants us to free ourselves when we are ready to do it. So if we grow, imagine a young child, like 6 months old, and you put it in a cradle, not because you don't love it, because you like to protect it. Because if you leave it outside, maybe he can go and do crazy things and kill itself or hurt itself. But if you keep this child and in the cradle, and this child will grow eventually, and hopefully, and become like 15 years old, the barriers will not stop it. She just put one foot outside and said, that was nothing. So what happens when it's ready? He will do it itself, and then it's another barrier. And when it will be ready, then it grows itself. So the barriers are very important because it's a protecting shield to our stupidity.
Thank you all. And the $1 million question now, of course, Depends on the exchange rate, right? As you mentioned before.
US dollar now
Yeah.
going down.
Yeah. So the $1,000,000 question, since talking about frontier space and the universe itself, is there a life beyond our galaxy?
May I?
Please.
This will take us, for a long discussion. That's one of the subjects also of my certain conference I give as well. So, what you saw in my presentation today are some slides that I took from that presentation. I didn't go into that far because that would take us, another hour or two. We don't know, to put it simple. We don't know, and I would like to put the following proposition. To the question, is life existing in the universe? There are only three possible answers. First, no, there's zero life. Life do not exist. Second, there's only one form of life that can exist. Third, there's an infinity form of life. And there's no other way of doing it. We know it's not the first answer because we are existing. So we are at least, we can say, we can exclude the first option because we know we are existing. So it's not zero. There is life in the universe. But we can still not decide whether it's one or an infinity. There's no 2 or 10 or 100. If life is a unique phenomenon, basically, that appear accidentally and happily for us on Earth, but accidentally because it was just a practical convergence of different conditions that made it happen, but it's an accident of nature, basically, that would be an interpretation, which could be perfectly correct. On the other hand, when you see the number of stars in the universe, the number of planets around these stars, we estimate that at least every star would have 1 or 2 planets. So you imagine number of billions and billions and billions of potential planets. Some of them could be at the right distance from the central star. Some of them could have harbored life as well, or at least the initial condition for the apparition of life, and so on and so on and so on. That's a famous formula from Frank Drake, who was an astrophysicist who introduced that in the 60s, so about 50, 60 years ago. And basically, you come, when you add up everything, you multiply all these factors together, you add up, you come up to something, say, okay, the probability is relatively small, but still non-nil. So that means that there could be life exist somewhere else. But that simply shows, quantify our lack of knowledge, because we don't know. Okay? So that's why it's so important as well to search life close to us, maybe on Mars, not on Moon. We know that life is not possible on Moon. Maybe on Mars, maybe on one of the satellites of Jupiter, or maybe one of the satellites of Saturn. Why is that? Because if it is a second genesis, so I mean that form of life should not be exactly similar to ours. If we can show that, for example, one bacteria was transferred from Earth to Mars, and that bacteria evolved, changed, and eventually gave another type of life. We know that analyzing the DNA, we could find some similarities, and then we could say, okay, that's not a separate form of life. But if we can find a separate form of life, second genesis, that would be answering the question. We know that if there is a second form of life, we know that there will be absolutely certain an infinity form of life in the entire universe. And that's something fundamental. But so far, we do not know. We have no answer. We didn't find anything. We do not know.
Thank you, Vladimir. Nikolaos? Or Patxi? Yeah, please. Yeah.
Well, I'm not going to add any technicality because the expert already exposed all the factors. But in my personal opinion, I hope so. It will be extremely boring to be the only ones around the block. So I hope that we have neighbors. But I always like to make this comment, which is taking the size that Vladimir was telling us about of the universe, which is so vast that we can barely conceive it. I always like to say that maybe we haven't found anything because it's very difficult for us to realize, because what we see is not what is there. And I always like to say that we all have a time machine in ourselves, and it's called your eyes, because every time that you look at the star, what you are looking at is not what is actually there. It's something that it might have disappeared already, but it will take you 1,000,000 years to see it. Or it might have been there and then the next day it's not there. So we have a time machine in our heads that we not realizing it. But when you look at the sky, you always look at the past, not at the present. And maybe that's something that it's difficult for us to see if there is someone else in there, because what we are seeing is something that happened maybe 10 million years ago. And maybe in that span of time already happened a life form, and there's something else that can realize, but we cannot see it. So it's a technicality frontier that maybe in the future we will be able to change. Yeah.
Thank you, Patxi and Nikolaos.
Of course, I don't know if there is life on the universe. I think also Vladimir has answered, and I'm tired to have another debate with him, so I agree with him. Yeah, one day. I'm just kidding, of course. And I love to have more debates with you. Well, if we compare life if our standard is life on Earth, I hope there is not another life elsewhere. Okay? We have the possibility of living here on Earth. We're just surviving. And so in this context, yes, I believe that there is life on the other outside of Earth, but actually not compare it with the life that we're talking about here. Here it's not life, it's just trying to survive everyday problems. We have a lot of problems right now that we have to overcome in order to reach the notion of life as I have it in my mind. This is not living. Generally speaking, I'm not speaking about individuals, I'm speaking about the concept of living. So, yes, this is my point of view right now.
Thank you. We have any questions from the audience? Yes, Mike?
Well, I think there are two questions, or maybe there are one. Why, if we don't trust ourselves as human beings, how can we trust AI? And why do humans invest such a big amount of money and energy and spiritual energy to make AI better if we don't trust AI? And why don't we invest this amount of money and this amount of energy to make us trust ourselves better?
I'm going to give you two answers. First of all, technically, AI is made by humans. AI is Vladimir pictured it as just a software that you can switch off, and then you can actually input another code, and then the code will switch off. That's the technical question that you'll receive from a technical person. Now, if we're going to a more philosophical part, can we trust AI? No, you can't. In a philosophical way, if we perceive AI as how everyone is picturing it, the Skynet and all this, at some point, if AI reaches the same level of consciousness, so to say, that we have, then you cannot trust AI as you can trust a human, as you cannot trust human beings. You cannot trust everyone maybe in this room, yes, but not maybe in the city. So same will happen with AI. So why are we investing so much money in doing this? It's because we want to understand ourselves better. So we really believe that if we are able to replicate us artificially, then we will understand us in every level, which I don't think is fully correct. But I think it's also a matter of I have to do it first, which it comes to ego. Like I did it first, I did it better, and as commonly mentioned, or commonly we say, like, mine is bigger. So I think goes in that direction, but it's a difficult question because it goes into a very philosophical answer.
Thank
You want me to?
you.
I believe in AI, and I say why not? It's a tool that it can help. I think we have to educate ourselves and our young people how to use it, to have a critical mind. I totally agree that you can have access to information, quick access. It can be a helping tool in a lot of aspects on your life, and you have to educate the students and the young people how to cross reference this information, how to judge if this is correct or if it fits, and not take it like this is the answer, and if ChatGPT says it, it's correct. I remember one student of mine, I was solving an equation in a board, and suddenly he said, you did it incorrectly. I found the answer, and she said, you are incorrect. And I didn't. I said, why? How you found it? I mean, he said, yeah, look, I found it. This is the answer. And I said, show to me. And he was using ChatGPT. He put the question and said, yes, but ChatGPT didn't consider this. Where is those parameters? So he trusted something, and he was insisting on he is correct, without having the knowledge to check if the answer is correct or not. So that is dangerous path. But if we taught our children and ourselves that how to use this tool, I think it's a very nice tool and wonderful tool. And why not? It's better to invest here than in bombs that can go kilometers down and destroy facilities. I'm not saying something.
Vladimir, I think he has a counter argument, Nikolaos.
Really?
Yes, out of nowhere.
Not of nowhere. I like to think that I have some humility, that I'm a humble person. I try to say, because I was told that from very early age, you have to never put yourself forward. But here I want to make a statement, a very strong statement, which will show that maybe I do not have this humility. I believe I'm more intelligent than artificial intelligence. So that's why I refuse to use artificial intelligence in any kind of business or writing or paper or research that I'm doing. And this is a clear statement, and always make it. That's me. I'm not trying to convince others. I mean, I accept that, okay, it can be a helpful tool. Not for me, and I do not want to educate my kids, my students, with whom I work from time to time. I let them do what they want, but I tell them, look, it's not a good tool in my sense, because eventually it will take over your sense of decision. I'm not talking politically or whatever, that's science fiction, but your sense of understanding how to do things. And I will take a simple example. GPS, it's not ChatGPT, it's not artificial intelligence, but you want to go from one place to another. Before GPS was available, what you do, you take a map and you understand where is north, west, east, you have to turn, third road around. I'm sure that Lavrini would agree. But now, of course, with GPS, it's so simple. You write the address in, and you don't need to understand where is you going. I mean, you just follow the indication. And if something is wrong, oh my God, where am I? Where is the sun? Okay, where is west, where is east? You do not know anymore. Because you do not use your own feeling, your own understanding, your own intelligence to try to find the answer. So for me, no artificial intelligence. No, thank you.
Thank you, Vladimir.
Thank you.
We have any other questions from the audience? Okay. We have one more question. And I would like to be respectful to any inquiries, either from the chat or the room. So the question is, because you talked about babies, Nikolaos, you said that we are really young babies in this universe. Patxi, you mentioned, to be innocent as a child, curious enough, with no preconceived notions, with no judgment, with no biases, just to have fun with it. And in my personal opinion as well, research is supposed to be fun. I think Einstein said that play is the most important form of research. So the question is, when we're born as babies, we are free. We don't care about anything or anyone. We do whatever we want. But when we get older, we start to fear things. So the question is, why is that? I mean, why when we grow up, we get scared easier? And this is also for Nikolaos, because he brought up this matter of being young babies, the babies of the universe, actually.
And again, what is the question?
So
Because
the question is, when we grow up, in contrast to our younger self, where we are fearless, right? Why we get scared easier? What changes along the way, basically, is the question, compared to being really, really young.
I think it's the environment that does a great job, and it helps us realizing that it's a very serious thing, what is happening right now. So a lot of fear is posing to us by our society and our parents, and it depends. So you can be brought up to be fearless, and you can be brought up to be, with fear. It depends on your first steps. So this is our innate characteristic is that we born to be completely free, and we have the conscious level that we're supposed to have. But when we start growing, I think we start making ourselves more of a need to really need artificial intelligence. So at this point, I prefer to have artificial intelligence, but rather than the intelligence of other stupid people. I totally believe that. I believe to have a critical mind using artificial intelligence and unintelligent people thinking that it's intelligent enough. So that's I prefer that. And so yes, the fear comes from it. And if we take everything so serious, it doesn't worth it. So this is what the young children should know, that they have to identify their limitation. Yes, there is a limitation on the human body. There is limitation in everything. They have to respect those limitations, but they have to use their mind, how to use the tools that is given to them in the specific time that they are living. We have to learn how to use those tools. Vladimir correctly mentioned GPS and the use of, yes, GPS is a tool. We have to learn to use it correctly, and also learn to use, when we don't have a GPS, also it's nice to know what to do. So yes, we use GPS. So I remember an example that I'm mentioning, a fellow, a friend of mine, a pilot. They were flying, and they lost all their navigation equipment during the flight. So they had two options: one, to get embarrassed and contact ATC and say we don't know where we are, how we land; and second, go back to the basics using CRP5 and do the calculations manually as they learned. And they did that, and they landed safely. So yes, we use the GPS. It's a helpful tool, but in case something happens, you use your intuition, and then you use yourself or your knowledge, and you get out of it. There must be a balance, but always return to yourself. So if you get lost, then you say, okay, let's go back and start from the beginning. So you have a critical mind. You use ChatGPT, you get an answer, okay, but let's see what it says. I completely agree that yes, I'm not going to use ChatGPT to produce a novel scientific paper. This is mine. Of course, I have to be within me. I will not use ChatGPT to produce something, but this is that's a point that you need to go to see how to use this in order to help you, not to be under control of it. Anyway, we are in control of the powers of this world anyway. So if you like to escape of it, you can do it. It's up to you. So the fear comes from that point of view, Chrysostomos, and we have to overpass that. We have to overcome that fear. There is nothing to fear about, and this is also something maybe the children should know. Also in Sweden, for example, in schools, and I'm mentioning that, and maybe Patxi or Vladimir would like to say something, but they learn how to move around frozen lakes, for example. They teach them that. So they say, yes, we have frozen lakes, and you have to respect it, and you have to know how to handle these situations, and it's nice. They don't leave it on ChatGPT, they don't leave it in other things, or in God, or in nature. So we will teach you, and these lessons are repeated every year and every year. So, at some point you will learn it. So they don't say don't go to the frozen lake because it's a danger, you can drown. That's the fear. No. You can go, but this is the preventive actions going there in order to maximize your safety. Different approaches.
Thank you. Anybody would like to share a comment?
Yeah, just a very quick comment about the AI. Current AI, I don't like to call it AI. This is basically a predictive model that we have right now. You will never get a novelty out of it. You cannot say, oh, give me a new paper for earning the Nobel Prize, or give me a new compound that is going to revolutionize the chemistry industry. It doesn't. It's not going to give you novelty. It's based on something that is already there. So the novelty is still within us. And that's why the AI, as wrongly called, is just a tool to use theoretically to make our life easier, but as Vladimir mentioned, what it's making is actually making us dumber, because we don't think. We just basically do things, and we lose it very fast, very, very fast. Very example of the GPS, we lose it extremely quickly. We don't realize that version. Regarding the question of the fear, I think the fear, we lose it in two steps. I think first, when we are born, we are a blank canvas that we just came to experience the world, and then our own survival instinct that is coded in our DNA is teaching us some fears, like touch the fire, it hurts, don't do it again. Water is cold when it's winter, don't do it again. And no one will tell you that. That's your own experience, your own brain and survival instinct who will put the boundaries of the fear, and they will stay there. Now, when we grow in the second step, then we have our parents, and our parents is the early society. And our parents will tell us, don't climb on the ladder because you might fall. Don't take those pills because you might poison yourself. And those are the secondary societal fears that are established. Now, when you step out of childhood, you might start challenging the initial fears. Like, fire is wrong, or if I'm very high, I might fall, I have a fear, but I want to fight it. And I will jump with a parachute to the thing. So you challenge those fears, and then you start overcoming those fears. But then you're developing another ones. Fear of speaking in public, fear of writing a paper, fear of trying to become something and become nothing in real life. So it's a set of back and forth all the time. I don't think we never lose them. I don't think we will never be fearless. But I think we should find the balance between the societal boundaries or fears that we have and the inner ones.
Vladimir?
Yes.
Final comment?
Yes, definitely. Fearless and fear, it's something that we all have inside us. I remember when I was a kid, because I will take my example, I was fearless in the sense that I was doing completely stupid thing, jumping from, first the high cupboard, then jumping from the window on the first floor, just try to see whether I can do it. When I was 2 or 3 years old, I received a little tricycle, which of course I was proudly pedaling around, but I said, well, maybe I can take the stairs with the tricycle. Of course I tried, it worked, so I'd take the second stair. And then it did not work because somehow it fell. And then I hurt myself. I still have a scar on one of my foot, but okay. But that doesn't just stop me to try it again until eventually I could do it. And then I tried the third, from the third, floor, going to land that. And then I felt really, really badly. Then my mother heard about it, and she said, "But what's this noise? What are you doing?" "Oh, well, I tried this and that. I heard, oh, you idiot." She was really angry with me, of course, but I was fearless, idiotically fearless, and I realized that. That fear did not go away because, growing up, I'm doing other stupid things, but maybe with potentially more damaging consequence. I rode motorbike when I was in Africa. I did things, without any protection. No, if you had an accident, there's no ambulance or no Red Cross that will come and pick you. You're in the middle of the jungle with friends and so on, but still, you break something, nobody will bring your motorbike back, and you have to walk, through the night, and completely crazy things. That now I realize afterward, and I have quite a lot of fear afterwards, saying, "Whoa, this is completely stupid. I shouldn't have done that." And I remember also talking with a NASA psychologist when I went through NASA selection, and he asked me also, "But what kind of fear do you have?" Well, I tell me exactly that, but say, okay, this is normal, this is when you were a kid, you were young, but now, what kind of fear? I don't know, I don't have any fear. I don't think, well, don't say that, because fear is something that will keep you alive. So never say that you have no fear, because that, in a selection board, that means that you're out of the equation. Why? Because nobody wants to invest in you, in an astronaut, or give you the responsibility of be part of a mission if you are not, let's say, clever enough to realize what are the risks. And then I thought about that. I said, yeah, he's perfectly right. So it's better to now study the kind of danger that can happen, the risk that you take, and try to find mitigating means to minimize that this danger would happen, that the risk would become real. And this is where actually you start to dominate your fear. You start to channel it into the good direction. So now, yeah, of course, with age, you get a bit more, fearful instead of fearless. When I was a kid, I could sit with my legs outside or walking on the edge of the roof. Now I get closer, say, "Whoa, how did I do that? It's completely stupid." But this is because first you get old, so probably you get more stupid, of course. Yeah, that's true. But second, you realize that the consequence of what you do. So you analyze the risk basically and say, no, something innate inside you would, tell you also, don't do it because it's too risky. It doesn't really, the balance between the risk that you take and the reward that you would out of it will not be sufficient. While fly in space, so you sit on top of a rocket, which is basically a huge bomb that can explode any time. Well, if it works, and hopefully it should, okay, fine, but you take a risk, but you still, the reward is you fly in space. So there's always a balance, so fearless and fearful, and there's always a balance to be found.
By the way, Vladimir, your early childhood reminds me of the picture. You were upside down on, right, on the parabola.
Yeah.
You were the one, right? You said that was yourself, right? So that just reminded me of being upside down
I just
during the parabola.
That I was an idiot to do that because it's fun to do, but you can't do it.
Thank you so much. So, our symposium is coming to an end, so allow me some final remarks before we conclude the second session as well. First of all, thank you so much to our keynote speakers, Vladimir, Patxi, and Nikolaos, for coming all the way to Naoussa. So I think a big round of applause for our speakers. It was truly a pleasure meeting you. We all enjoyed, I think, the interaction, even the harsh debates, right? I'm just exaggerating.
I still don't agree.
You still don't agree, right? No, the very fruitful debates. He's taking the bus back home. He's not flying back, right? But it was truly a pleasure. So thank you so much. At this point, would like to really thank educational entity Ensyntropy based in Sweden, because if it was not for Ensyntropy, this symposium would not have taken place. These keynote speakers would not be here, and we would not be talking about those things. So we express our gratitude to Ensyntropy on behalf of the association because they are definitely a driving force to everything we do. So a big thank you to Ensyntropy as well. We would like to thank the Aristotle School. It's been our venue for the past 4 years. It's not just the venue itself, it's the symbolism of Aristotle, his philosophy, his educational approach, and his relationship to Alexander the Great. So it's always really nice to be here and be hosted here. Would like to thank the boutique hotel Paleapoli for providing really kind and generous accommodation to our speakers, and our communication sponsor Naoussa, who for the past 2 years has been also spreading our messages and our press releases in every way they can. Technical support, brothers Thomas and Elias Chimbris, thank you so much for the audiovisual support, for all the knowledge you shared with us in terms of the live streaming and not only. So thank you both. Okay. And of course, thank you, all of you, for being here, our live stream participants, for spending time with us. We hope you found it as productive as it could possibly be, as transformational as we originally planned it and designed it. But all the times, our symposia, it's by far they exceed our expectations, and I think this is the 4th time that another symposium is beyond what we imagined, and even more. So thank you all. It was truly a pleasure.